right, so before you watch this video, you need to make sure that you completed the lesson from yesterday. So you may need to go back and click yesterday's agenda, make sure you watch the 10.3 notes where we introduced the area of regular polygons, but we were able to use special right triangles to find all the areas. Because today we're going to step it up a notch and go back to trigs. Not every regular polygon can be kind of redrawn using special right triangles. So just to review, trig is a way to use ratios to relate sides and angles in a triangle, and it's specifically a right triangle. And so we've got these three ratios: sine, cosine, and tangent. And remember, this acronym, SOHCAHTOA, is used to help us remember those ratios. So opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So remember, a regular polygon is a polygon that has all congruent sides and all congruent angles, and the formula for the area is 1/2 times the apothem times the perimeter. And the apothem is the segment that's drawn from the center of your polygon perpendicular to the opposite side. Okay? And it can be drawn to any one of these sides. So I could draw this segment right here and call that an apothem. I could draw this segment right here and call that an apothem. I just usually go straight down to the opposite side. All right, so we've got a regular nonagon. So that means that it has 9 sides. And we're given that all the sides are 10 centimeters long. So remember, another thing that the apothem does is it divides the side in half. So I'm going to go ahead and I'm going to label each of these sides then as being 5 centimeters. And so what we need to do, we're going to use this right triangle right here to help us find this segment, which is the apothem. We know that this is 5 centimeters. So what we need to do is figure out what this angle is. My hand is in the way. Figure out what this angle is so that I can use either a special right triangle relationship or trig to find that side. All right, and so if this is a nonagon, if it has 9 sides, that means that when I think about this entire inner little circle, all of the central angles in here will have the same measure. So if I take 360 and divide that by 9, I get 40 degrees. So this entire angle right here would be 40 degrees. But I am only concerned with half of that. So when I divide that by 2, I get 20 degrees. That's this angle right here. So now that we can use either special right triangles or trig, this is where you decide which method to use. If you create either a 60 degree, a 45 degree, or a 30 degree, I can't remember if I already said 30 or if I said 60, but those are the special right triangles: 30, 60, 90, 45, 45, 90. So since this angle is 20 degrees, that's not going to use any special right triangles. I'm just going to redraw this a little bit bigger over here. So this angle is 20. This is the side that I am going to be trying to find. All right, and so now I need to figure out which trig ratio I'm going to use. So when I label the sides according to this angle, and you could find this one, you just don't really need to. It would just be an extra step you don't need to do. So this 5, that would be my opposite side. And then this X, that would be the adjacent side. Because remember, that side across from your right angle is always the hypotenuse. And so if I'm given the opposite and I'm looking for the adjacent, I'm going to want to use tangent to figure that out. So my equation would be the tangent of 20 equals opposite over adjacent, 5 over x. So we always are going to start by getting rid of that fraction. So I'm going to multiply both sides by x. We'll cancel that out over here. And then to get the x by itself, I'm going to divide by the tangent of 20. And we're going to be rounding our answers here to the nearest tenth. If you can use special right triangles, you need to keep your answers with the simplified radicals. Okay. All right, and so the first thing I'm going to do, make sure if you're using the Texas Instrument Calculator, this right here should say DEG in degrees. You shouldn't have had to change it from what we did before spring break, and so it should be okay. So if I take 5 divided by tangent of 20, I'm going to get about 13.7. And then my units are centimeters. So that is the length of the apothem. So the other part of that formula that I need is the perimeter. Well, if each side is 10 centimeters and there's 9 total sides, that means the perimeter is going to be 90 centimeters. And so now I have enough information to find the area. So 1/2 times 13.7 times 90 is going to be 616.5 centimeters squared. Now, if you're having trouble with your calculator, you need to reach out to me, either through Remind, Canvas, come to Canvas conferences so I can see your calculator, but you need to make sure that you remember how to type this in on your calculator. I'm happy to help you do that. You just need to let me know. All right, so now let's look at this next one. So what is the area of a regular pentagon with 4-inch sides? So I'm going to start by drawing in my center. Here's my apothem. There's the other segment that I'm going to use to create this right triangle right here. So if the sides are 4 inches, that means this is going to be 2 inches. If you want to start, you can find the perimeter first. That's kind of the easy part. So if each side is 4 inches and there's 5 sides total, that means the perimeter is 20 inches. And so now I need to figure out this apothem to help me find this area. So in order to do that, I need to figure out this angle. So we're going to take that same process. Figure out the total angle first. So 360 divided by 5 is 72. And then I'm going to cut that in half because that angle, this whole angle right here, is being bisected by the apothem. So that means that inside angle is 36 degrees. Okay, that's big enough. I'm not going to redraw that out. I'll just keep that here. So now I'm still going to be using tangent, right? And honestly, I would say 98% of the time you'll be using tangent because this is going to be pretty much the process that you're going to need to figure out unless you're given this and you have to kind of work backwards to get that other side. But since this is the hypotenuse, and that is in both sine and cosine, if you are given this, you're not going to be using either of those ratios. All right, and so my equation then would be tangent of 36, opposite over adjacent. Always start by clearing the fraction, regardless of where your variable is. So now I have x times the tangent of 36 equals 2. And then sometimes that might get the x by itself. In this case, it doesn't. All right, so now that cancels out. You have 2 divided by tangent of 36. We're going to be rounding to the nearest tenth, so that 5 is going to bump that 7 up to an 8. All right, so now we have enough information. We should be good to go to find our area. So 1/2, we just said the apothem was 2.8, and we said that the perimeter was 20. And so that is going to give me 28 inches squared for the approximate area. All right, let's look at one more example. So this one says, what is the area of the octagon stop sign if the radius is 16.2 inches? Okay, so here's kind of one of those special cases that I was just talking about. Now we're given that the radius is 16.2 inches. And so remember, the radius is drawn from the center out to one of the vertices. So this is now going to be 16.2 inches. So this is going to be a little bit longer of a process, because if I need to find the area, it's 1/2 times the apothem times the perimeter. I need to figure out what the side length is so I can find the perimeter, and I need to find the apothem. So we're going to have to do trig a couple of different times, or we could incorporate the Pythagorean theorem as well to help us find those two missing sides. But we're going to go ahead and we're going to start with trig. So I need to still figure out this angle measure right here. So 360 divided by 8 is 45. So when I divide that by 2, I get 22.5 degrees. So from here, you need to decide which side you want to find first. It doesn't matter. Your answers may be off a little bit, like by 1/10, because we're going to be rounding essentially 2 times, but it should be fairly close. I'm going to go ahead and find this side first. Okay. So in terms of this triangle, this is our opposite side. Now the 16.2 is the hypotenuse. And so I need to figure out what trig ratio I'm going to use. So if I'm given the opposite, well, I'm not given the opposite, I'm trying to find the opposite. I'm given the hypotenuse. That means I'm going to use sine, opposite and hypotenuse. If you were going to find the apothem first, that would be the adjacent side, so you'd be using cosine. All right, so my equation is going to be the sine of 22.5 opposite over hypotenuse. Always start by clearing your fraction. And this is going to be nice because I won't have that extra division step at the end. The x is by itself. So once I multiply 16.2 times the sine of 22.5, it's going to be 6.2. So that's this right here. Okay. And so now what that means is that this side is also 6.2 because the apothem is bisecting it. So I'm going to go ahead, before I find that other side, I'm going to find my perimeter. So all the sides are about 12.4 inches. So the perimeter is going to be the side length times the number of sides. So it's going to be 99.2 inches. So there's the perimeter of the octagon. Now here I might suggest using the Pythagorean theorem instead of trig again. I just think that's probably something you guys are a little bit more familiar with, but if you wanted to do trig again, you'd obviously be more than welcome to do that. So I'm going to go ahead and just put the a there since that's the apothem. And so my equation for the Pythagorean theorem would be a squared plus 6.2 squared equals 16.2 squared. Now this is a mistake that I noticed several people were making in 10.1 and 10.2 with the Pythagorean theorem. Make sure that you are subtracting this. A lot of people have been adding, but we're trying to undo that. So 16.2 squared minus 6.2 squared is 224. And then when I take the square root of that, let's see, that's actually going to round to 15 because that 6 bumps that 9 up, and so that would be 15. So that would be the length of our apothem. Now we can find the area. So we said the apothem was about 15, the perimeter was 99.2. And so that would make my final area 744 inches squared. Okay. All right, so your homework tonight is kind of a combination of 10.3 and 10.5. So part of your job when you're finding the area is to determine whether you're looking at a special right triangle or not. So remember, you tell that by figuring out, or once you figure out what this angle is right here. If it's either 30, 60, or 45 degrees, your answers should be exact because you are using special right triangles. If it's not one of those angles, then you'll have to use trig. Okay, just let me know if you guys have questions.